Okay, so today we're going to look at 3x3 matrices and how to find the determinant of a 3x3. Well, if you have the following matrix A with the following elements, here's the formula for finding the determinant. The formula looks really scary, but finding the determinant of a 3x3 matrix is not that difficult. It looks a lot more difficult than it actually is. There's a little trick you can do. So what you're going to do is you're going to take your matrix, you're going to take your elements, okay? And what you're going to do is you're going to list them out. Okay? So here's what I'm going to do. I'm going to take my first two columns of my matrix and just move it to the end of my matrix, like I have over here. Okay? This is your first column, this is your second column. I'm just adding it to the end of my matrix. Now, I want you to take a look here. A sub 1, B sub 2, C sub 3. That's right here. So you multiply those together, and then you add it to this multiply together. Then you add it to this multiply together. And you treat that as one big quantity, put that in parentheses. And then just like with 2x2s, when you find the determinant, you subtract. So then we're going to subtract here. We're going to use subtraction. And now what we're going to do is we're going to multiply these together. These together. These together. And add those together. Okay? And that's how you find the determinant. It's really not that bad. It looks, like I said, it looks more complicated than it actually is. So let's do an example here. Alright, so there's the pattern up there again. So remember when you have a matrix and you have absolute value symbols around it, that means you want to calculate the determinant. So our first step in calculating the determinant of a 3x3 is let's just list out our first column, our first column and our second column. Just add it to the end of your matrix. Okay? And now you're going to start with your main diagonal. So I want to multiply these together. So, I have a little technical difficulties here. Let's see if I can get a highlighter. So we're going to multiply these three numbers together. Then we're going to multiply these three numbers together. Then we're going to multiply these three numbers together. So let's start with our first one. Negative 1 times negative 4 times negative 1 is negative 4. Plus 3, now we're using this one. 3 times 6 times 0 is 0. Plus, now we're going to use this one. 5 times 2 times 1 is 10. And then I'm going to subtract that. Where I'm going to subtract that from? Well, I'm going to multiply these together now. Alright? So let's start with this one. 0 times negative 4 times 5 will be 0. 1 times 6 times negative 1 is negative 6. Negative 1 times 2 times 3 is negative 6. And when you do that, when you do your other diagonals, make sure you put them in grouping symbols. It's important that you add them together before you subtract them. Same over here. Add these together before you subtract it from the number at the end. So negative 4 plus 0 plus 10 is 6. Minus, what do we got here? negative 12. So 6 minus negative 12 becomes 6 plus 12, which is 18. So the determinant, let's just call this matrix A, is 18. The determinant of this matrix would be 18. All right, so now let's find the determinant of B. Why don't you pause the video and try to do it on your own? See if you can find the determinant of B before we work it out here. All right, so hopefully you had some time to work it out and see what we end up with. So again, our first step is to take my first column and just extend it to the end of my matrix. Take my second column, extend it to the end of my matrix. And now we're going to multiply along our diagonals. I'm going to highlight the ones that we're going to use first. We're going to do multiply these three numbers together, multiply these three numbers together, multiply those three numbers together. So what do we get? 3. Negative 3 times negative 5 times 3. That's going to be positive 45. 4 times 1 times 0 is 0. And then 0 times 2 times 2 will be 0. And then we're going to subtract that from another quantity. So to get that other quantity, we're going to use the other diagonals that go from right to left. So multiply these, multiply those, and multiply those. So let's do the first one. 0 times negative 5 times 0 is 0. 2 times 1 times negative 3 is going to be negative 6. 3 times 2 times 4 is going to be 24. So what do we got here? We got 45 minus, what, 18? So 45 minus 18, what is that? 27. So we can say the determinant of B is 27. That's how you find the determinant of a 3 by 3 matrix. Now yesterday, we were using Kramer's rule and determinants to solve systems of 2 equations. Well, today, I want to take it a step further. I want to use Kramer's rule to solve a system of 3 equations. It's no different than a system of 2 equations. It's just a little more steps, okay? So you're going to start off by finding D first. So what is D? That's your coefficient matrix. So you're going to list out the coefficients. Well, we got our 3 equations, right? In equation 1, the x coefficient is 0. The x coefficient in equation 2 is 1. And then in 3, it's 2. Now let's list out the y coefficients. So we got 1, 1, negative 5. List out the z coefficients. We got 4, 1, and 0. So this is your D. And remember, when we use Kramer's rule, we're doing determinants. So now I want to find the determinant of B. So it's just like what we just did. So list out the first 2 columns. Okay? Let's highlight our diagonals that we're going to be using. We're going to be multiplying these 3 numbers, these 3 numbers, these 3 numbers. So 0 times 1 times 0 is 0. 1 times 1 times 2 is 2. 4 times 1 times negative 5 is negative 20. And then it's always subtract. What am I subtracting? Well, I gotta use my other diagonals. I go from right to left. So let's use those. So we're gonna be multiplying those three numbers, these three numbers, and those three numbers. So start with this one. 2 times 1 times 4 is 8. Negative 5 times 1 times 0 would be 0. And then 0 times 1 would be 0. So let's see. What is D? D is equal to negative 18 minus 8. So D is negative 26. Okay? So now what do we want to do? We want to find D of X. So let's find D of X now. Or just like you did yesterday, what you do is write out D of X first. Okay? So remember, this matrix here is my D matrix. How do you find D of X? Well, you take out the X coefficients and replace them with these numbers. So D of X would equal the following matrix. 5, 8, 7, and then these are all the same. So now, let's evaluate what D of X is equal to. So let's find the determinant of D of X. So write out your first two columns. Alright? Let's highlight the numbers we're going to be using. 5 times 1 times 0. 1 times 1 times 7. 4 times 8 times negative 5. So D of X is going to equal 0 plus 7 plus, what is that? 4 times 8, 32 times 5 is 160. It's one negative sign, so negative 160. Minus, let's do other diagonals. Let's do a here. So we'll go 180, negative 515, 417. So what do we get? We get 28 plus negative 25 plus 0. So D of X is equal to negative 153 minus 3. So D of X is equal to negative 156. Just write that up there. D of X is equal to negative 156. Now we would find D of Y. And we would do D of Y the same way we found D of X. We would replace the Y coefficients. And then we would find D of Z. But luckily they gave us a hint and they already gave us D of Y and D of Z. So now, to find your solution, just like you did yesterday, you do D of X over D, D of Y over D, D of Z over D. So my X coefficients would be negative 156 divided by negative 26 is 6. My D of Y will be negative 26 divided by negative 26, which is 1. And then D of Z will be negative 26 divided by negative 26, which is 1. So the solution to this system is the point 6, 1, 1. Questions? If you have any questions, you can email me. I will be holding some Zoom meetings, help sessions.